Numericals on motional EMF. An aeroplane is flying horizontally from west to east with a velocity 900 km per hour. Calculate the potential difference developed between the ends of its wings having a span of 20 meters. The horizontal component of Earth's magnetic field is 5 into 10 power minus 4 Tesla and the angle of dip is 30 degrees. Let's consider the solution. Here velocity is given as 900 kilometer per hour. So that can be written as 900 times 5 by 18 meter per second, which will come out to be 250 meter per second. Now, we are given BH as 5 into 10 to the power minus 4 Tesla, and we have to find out VB. So, this is V, this is delta, this is BH, this is VB. So, perpendicular component is VB, which is B sine delta. So let's see the relation between BB and BH. BB upon BH, and BH is B cos delta. So if we write B sine delta divided by B cos delta here, so we will get time delta. From where we get BV equal to BH time delta. So we put the value. So BV equal to BH. BH is 5 into 10 to the power minus 4 times tan delta. Tan 30 is 1 upon root 3. And motional EMF equal to BLV. So B is 5 into 10 to the power minus 4 into 1 upon root 3 times length is given 20 meter. 20 into velocity is 250. If we evaluate it, so 1 upon root 3 is 0.577. So 5 into 10 power minus 4 into 0.577 into 20 into 250. So this will come out to be 1.44 volt. Now let's see next question. PQ of a rectangular conductor is moving from x equal to 0 to x equal to 2b outwards and then inwards from x equal to 2b to x equal to 0 with a velocity v as shown. A uniform magnetic field perpendicular to the plane is acting from x equal to 0 to x equal to b. Obtain the expression for flux, induced EMF, force and power dissipated. Plot the variation of these quantities. So it's clear that field is limited up to x equal to 0 to x equal to b. Then from x equal to b to x equal to b, there is no field. So flux will change from here to here, means from x equal to 0 to x equal to b. And then from b to 2b, flux will remain constant. When we take it back, then from 2b to b, there is no change in flux, but from b to 0, there will be change in flux. So we can write flux phi will be BLX because x is this distance which is changing from x equal to b. So since this will happen from x equal to 0 to x equal to b, so limit we write like 0 is less than or equal to x is less than or equal to b. And then from b to 2b, phi will be constant, which will be same as x equal to b. So BLB. From b is less than x, it's less than 2b. Now we consider induced EMF. So induced EMF for this portion means from 0 to b. So it will be E equal to minus d phi by dt. So this will be equal to minus, and differentiation of x will give dx by dt will give velocity. So BLV. And then since flux is constant, then E will be 0. for the range B to 2B. So this is 0. So this is part 0 is less than or equal to X is less than B, and this is from B is less than X less than 2B. Now we consider induced current. So I will be PLV upon R. We assume that this is resistance of the movable part, that portion PQ. And then we find force. So force equal to P square L square V divided by R for portion 0 to B. B. Here force is BLV. Here this is flux. Flux is changing from 0 to B. Then from B to 2B it is constant. Then when we come back from 2B to B, it is still constant. Then it decreases to 0. And EMF induced from 0 to B, it is minus PLV. And when the conductor is brought back, so while moving from portion B to 0, velocity is leftward. In that case, EMF induced will be positive. That will be BLV. Now we find force. Force is B square L square V divided by R. It will be negative when conductor moves from left to right, and it will be 0 between V to 2B. So F equal to 0 from B to 2B, and then during backward motion again from 2B to B it will remain 0, and then it will become positive. So when motion is towards right, velocity this will become negative. So negative portion is represented here. Force is negative from B to 2B, and then from B to 0 coming back, this force will be positive. Now we consider power. So power is I square R. So every term will become positive, means it will be B square L square V square upon R. This is derived from relation F into V. When this force is multiplied by velocity, we get B square L square V divided by R. Resistance can't be negative. Here V, this is square, this can't be negative. This is also square, this is square. So all terms are square. So power will always be positive, whether motion is outwards or inward. That is why it is represented by this B square. Its value is corresponding value. This value is equal to B square L square V square upon R. And this is in when motion is outward, and when motion is inward, still this is portion B, and this is 0. So when motion is from B to 0, still power is positive, that is B square L square V square divided by R. I think you must have understood. This is very important question for CBSE exam. Thank you for watching.